Given a 2D grid, we'll visit every position of this 2D grid in the clockwise spiral order. Design an algorithm to output the list of coordinates in the spiral order. That's about today's video. Let's dive in. San Francisco Bay Area, or Silicon Valley. This is where my dream started. This is Steve here. Today we are going through another follow-up of the spiral matrix. This is a series. Right now there are only 3 problems related to spiral matrix, so I believe this is the last one right now, but I don't know if they are going to continue to add more follow-ups for this spiral matrix series. But I thought this is a very interesting question, so let's go through this one. Let's take a look at the problem description first. So on the two-dimensional grid with R rows and C columns, we start at R0, C0 facing east. Here, the northwest corner of the grid is at the first row and column, and the southeast corner and the northwest corner. In the southeast corner of the grid is the last row and column. Now it's very intuitive. Like we start from the top left, right? Which in this description is just the northwest, and the bottom right, which is just the southeast. Very intuitive. Now we walk in a clockwise spiral shape. It's saying spiral shape here. To visit every position in this grid. Whenever we would move outside of the boundary of the grid, we'll just continue our walk outside the grid, but may return to the grid boundary later. This is where the confusion is going to start. So let's take a look at, so eventually we reach all R times C spaces of the grid, return the list of coordinates representing the positions of the grid in the order they were visited. So let's now take a look at this example here. The example given row number, the total of 1 row, total 4 columns, and we start from 0, 0. So we start from here. This is where we start. 1, it's facing east. It goes towards the east. And then towards the east, it goes towards, so here, this is the key. We walk in the clockwise spiral order. Clockwise spiral order. It's not directly going to all the way from left to right. It's not how it's working. It's walking from here towards the east side, and in only one step at a time. So the direction is you move one direction towards the east, then one direction towards the south, one direction towards the west, and then after finishing this round, these 4 sides, it will increment it by one more, by one step more, by one position more, whatever you want to call it. So let's look at this. So 1 to 2, it doesn't go towards the east, it goes towards the south. South is outside of the 2D grid, so it's going towards the left spiral matrix, clockwise spiral matrix, towards the left. And then it's still out of the boundary, so it's going north. Still outside of the boundary towards the east. Notice this time it's adding one more position, right? Because this one we have traversed through already. It doesn't need to visit the position at 2 again, so it's visiting 3, right? 3, it's moving towards the east, so it reaches at this correct position. It's going to come to the south again, and then it's going to revisit every single one. It's just going to keep continue. How do we? Okay, let's take a look at the second example. Then we'll have a better understanding. So given 5 rows, R equals to 5, 1, 2, 3, 4, 5. There are 5 rows. C equals to 6. There are 6 columns. 1, 2, 3, 4, 5, 6. 6 columns. And this one, it doesn't start from the northwest corner, right? It's starting from a more generic position, which is 1. 1 is here. The first row is here. And the 4th column is 0, 1, 2, 3, 4. This is the 4th row. So it's starting from here. Spiral, clockwise spirals towards the east to and 3 and 4, and then towards the north, 5, 6, 7, 8, and then it's going outside of the grid, and then move down here, but it's not going to revisit everything it has visited already. So it's going towards here, towards the west, and towards the north, boom, down, down, down. This is how it's visiting every single position of this 2D grid. The tricky part is that it can go outside of the 2D grid. How do we handle this case? Let's think about it. There is a common technique that I would like to introduce. This is the problem is, this is LeetCode problem 885. So I'm going in the random order. But the common technique that I'm about to introduce is going to apply to a lot of 2D grid problems. That is, we can use a four direction array to help us control the flow. What do I mean by that? Let's quickly draw something. Say this is the center. We'll call it at position 0, 0. What do I mean by an array of directions so that we can better control the flow? Either go towards east, south, west, or north. Let's take a look at what I mean by that. So on the right side, on the east side, how do we denote the coordinates that's on the east side of 0, 0? It's going to be 0, 1, right? This is the coordinate. This is the position that's on the east side, on the right side of 0, 0. So we'll just use 0, 0 as the center point. Let's just highlight this one. This is on the east side. How about the one that's on its south side? It's going to be what? It's going to be 1 plus, right? A row is going to plus 1. So we'll just use these two integers to represent x coordinate and y coordinate. I hope everyone is still with me. And then on the right side is going to be column plus 1, right? So still on the same row, so row is 0. And for the one that's on the south of it, it's going to be row plus 1, but column is still the same. All right. And then the one on its, left side, on the west side, is going to be still the same row, but column is going to be 1 minus 1, right? Oops. This is better. Okay. Right. These are the 3 positions. And how about the one that's on the north of the center position? That's going to be, a row is going to be 1 minus, right? Minus 1. Column is still the same, right? These are the 4 directions that we can use these 4 directions to control our flow. And how do we put these 4 directions into just a one-dimensional array? We can use, so say starting from here, it's very interesting that it's continuous, it's consecutive. So starting from 0, 1, and then 1 is consecutive. This is also starting from 1. This is ending with 1. This is starting from 1. So we can easily use this array to represent it. You can either use a 2D array or a 1D array. Either way is fine. So I'm just going to use a 1D array, which is going to even simplify or might add some confusion. But I think if you understand this and you'll get used to this, and things will be easier. 0, 1, and 1. And then what do I mean? What do I mean by that? We'll go through that after we walk through the code. 0 minus 1. So here, this is 0, 1, 0, 1, and 1, 0, 1, 0, and then 0 minus 1. We're going from towards the east and go clockwise, right? So east, south, west, north. So we're going this way. So east is here, 0, 1. And then south, 1, 0. 1, 0 is here. And then west is 0 minus 1, 0 minus 1 here. And then north, minus 1, 0, minus 1, 0. So we'll call this one directions. We'll use this to control the flow of our direction. So now back to this problem. How can we apply that 1D array of directions to this problem to help us solve this problem? well, we can use that 1D directions to help us control the flow. So like say we go east, we just use these first. If we go east, we can just keep using these two elements to control the flow. How do we actually do that? Let me, before we write any code, before we start writing the code, anything else we need to know about this? Let me think about it. The algorithm will go like this. So first, one clarification that we need to do is the size of this, the size of the final result, which is going to be, let's call it matrix. That's the first confusion that I had when I first tried to, because I know the indices of the arrays, especially 2D arrays, will be kind of confusing. So looking at this final result, this is the final result here, right? So the number of rows is going to be R times C, right? So this is a bit too big, but for this one, the number of rows, so there are a total 1, 2, 3, 4. There are 4 rows in this 2D array and 2 columns, right? I hope you guys are still with me. The same is true. Where does this 4 come from? 4 comes from 1 times 4 equals to 4. And here, there are so many rows. How many rows are there? There are a total of 30 rows. Where does 30 come from? 5 times 6 equals to 30. So 30 rows. And the number of columns for the final output is always 2, right? Why? Because it's always x and y to indicate the 2 coordinates of one position in this 2D grid. So that's the first point that I like to make it clear is R times C, and number of rows is always 2. That's the final result that we need to output matrix. Then how do we go about filling out this matrix with the correct coordinates in the correct order? We'll start from the given R0 and C0. We'll start from there. Then we'll use one variable, just called I, to indicate the number of rows that the current one that should be filled into the final result. Use I, which is going to start from 0. And then let's fill out the first one into the matrix first, which is going to be I, and then we'll increment that. That's going to be this one, the given one, which is the very first one that we're going to start with, R0 and C0. And then from here, let's just look at the second example, which is more generic. Where should we go from here? We'll have a while loop, very similar to the previous 2 spiral matrix problems. We'll have a while loop to control the entire flow, as long as I is smaller than R times C, right? That means we have, for example, for this second example, 5 times 6 is 30. And I starts from 0. So as long as it's smaller than 30, we'll just continue. Then how do we control the flow inside this while loop? It's starting from 0. When it goes towards the east, this is the first time, it's going to be 1. So we'll increment it. Let's see. We'll use one variable. We'll call it length or width or whatever. This one is going to increment. Start from 0. And if we'll use another variable called, we'll just call it D, stands for directions. And we need an integer array, which we just went through, directions, new int, which is going to be 0, 1, 0, minus 1, and 0. Let me check if it's correct. 0, 1, 0, 0, 1, 0, minus 1, 0, minus 1, 0. Yes, that's correct. Okay. So if, like say, we start D0 just stands for towards the east. Let's just call it that way. And then D will just be 4 values because we have 4 directions, 0, 1, 2, 3. So 0, we'll just call it, it's moving facing the east. It's moved towards the east. So if D equals to 0, we're going to increment I, because we start the length with 0, and then we get into this while loop. We're going to move towards the east by 1 position, right? We filled the first position already. and then we're going to increment length by 1. Which the reason I wrote this is because every time we move towards the east, we're going to increment the length by 1. How are we going to use this length? We'll have another variable because we'll keep moving towards the east, right? We'll keep moving towards the east, keep moving towards the east, keep moving towards the east, whether it's outside of the boundary or not. If it's outside of the boundary, we're just going to ignore that value. We're not going to assign that value into the final result matrix. So here, int any variable. I'm not going to use j because it will be confusing, because in my mind, j is always indicating the column index. So I'm just going to use I equals to 0 as long as k is smaller than length. K is going to continue to increment. This is just a counter. K is not going to be used in this in the for loop. What do we do in here? We're going to increment. We're going to modify the row index and column index. So it's going to be R0. We're always going to use a increment sign, but it could decrement. Why? Because we have negative value here. That's the beauty of using this technique, directions. Let's see, how do we actually use the directions? D. Let me write this and I'll explain. C0 is going to be D plus 1. This is where this directions array really comes in handy. So directions, say D, we start from 0. So D0, at this moment, D is 0, right? And D plus 1 is 1, so 1. So that means we are doing R is going to plus 0. So that means it's going to be at the same row, but column is going to be plus 1. So that means column is going to move towards the east, right? So move towards the east. Move towards the east. So after these two lines of code, R0 and C0 will be standing at the correct current position. And then, just in case, because it's totally possible that, say, right now it's R0, C0 will be at this position, which is 1, 5, right? But then if we continue, there are cases if we continue to move, it's going to be outside of the 2D grid, which is, we're going to check if R0 is smaller than R and R0 has to be greater than or equal to 0, and C0 has to be smaller than C, which is very intuitive as well. You have to make sure that both R0 and C0, the current row index and column indexes that we just computed based on directions, need to be within the boundary, within the 4 boundaries. So C0 is greater than or equal to 0. Only in this case, which means the indices that we compute for this position is still within the boundary. We're going to add this into matrix. Matrix at this point is I. I is going to increment after that, and then new int, and R0 and C0. This is R0 and C0 matrix I. I is the number of rows that we currently should assign the coordinates into. So we'll keep doing this until we exhaust, until we finish this row. And then how do we change from the going, right now it's facing towards the east. After going, so move towards the east. At the beginning, we only move towards the east for one position. After moving towards one position, we need to go south, right? Then how do we control the position? We'll just do, remember, direction is controlled by D. There are only 5 elements in this array, but it's actually standing for 4 directions. So directions will always be from 0, 1, 2, 3. You will only be one of these 4 values. So how do we control that? We'll just from 0 standing for facing towards the east, 1 standing for towards the south, 2 standing for towards the west, and 3 standing for towards the north. That's all. So it's in the spiral order, in the clockwise spiral order, which serves our needs. So that's going to be d plus plus. So it's going to from 0, 1, 2, 3. But if we continue to add d in this way, it's going to be like multiple rounds. It will go like bigger than 3, right? Which is wrong. We don't have that many values. So we're just going to use a modular sign, modular 4. That's a quick small trick, which is going to give us the correct, that's going to be, we'll increment d first and then modular 4. So this way, d will always be one of the 4 values, which is 0, 1, 2, 3. That's it. That's how we control the directions. Okay. Now let's start from the beginning again. So we assigned the very first R0 and C0 to the very beginning, which is correct. 1 and 4, which is 1 and 4 here. And then we come into this while loop. We check if d is facing towards the east. We're going to increment length by 1 because length starting from 0. And then we check here, its k starts from 0, is smaller than 1, so which is good. We're going to increment it once. Now it becomes 1, 5, and then we exit out of this for loop. We'll increment d by 1, so d is 1 now. Modulo 4 is still 1, so that means we're going to go south, and then length is still 1, which is correct. We're going through south, moving from 2 to 4, moving from 2 to 4. So we're going to get here, direction is 1, so 1, which means row is going to plus 1. And then here, plus 1 is 0. So that means column doesn't change, which is correct. We're going south. It's going to be the same column, but row is going to be plus 1, which is correct. And then we'll get out of this for loop, and then we'll increment d again. So d becomes 1, 1 plus 1 is 2, 2 modulo 4 is still 2. So d is 2, which means moving towards the west, right? Moving towards the west. And then we'll check, right now, do we need to increase the length? I think we do need, right? So right now it's at 3. So 3 is going to move, if we just move 1 position, it's going to end up at 4 and then go north. It's not correct, right? Because we have just finished visiting. We start from 1. So right now, length needs to increment 1 position. So it's going to visit, we're going to move west 2 positions at this time. So we'll add one more condition here. Or d equals to 2. 2, again, direction 2 just stands for we're moving towards the west. When moving towards the west, we'll move 2 position towards the west. So from 3 to 4 to 5, we move 2 position towards the west. Then from west, do we need to increment or just increment the length? Do we need? We'll see. From 5, we move to 6 to 7, right? 2 positions. From 5 to 6 to 7, 2 positions. That's good enough. So length, we don't need to change it. And then we move from 7 to 8 to 9, right? So 2 positions. But if we just stop at 9 and continue to go south, which is wrong, we have visited this already, which means we need to go out of the boundary, right? We need to move, boom, out, fall out of this grid. That means this, again, this is moving towards the east. Which direction, which number stands for moving towards the east? 0. That's why we have a 0 here. So this is still going to hold, right, for the rest of the loop, for the rest of the cycles, clockwise spiral order. That's why we have, so when we move towards the east or move towards the west, we're going to increment the length by 1 because we need to, we don't want to revisit everything that we have done already. That's why we have, when we move towards the east or towards the west, we'll just increment the length by 1. And when we visit one direction, we'll just traverse through. For every row index and column index, we're just going to modify it based on the directions. That's it for this. And also we have a check here to check whether this newly computed row index and column index, they are within the boundary, within the 2D grid boundary. If they are, we'll just add that into the matrix and then increment this matrix row index by 1. That's it. For this algorithm, let me just double check before we submit and see. Yeah, it looks good to me. Let me hit submit and see. All right, accepted. That's the algorithm. A big shout out to one of the users on the Discuss board who come up with this solution. Um, this is really cool. If I have to think about this solution, I come up with a very lengthy solution. Then I spend quite a lot of time to figuring out the corner cases, which is very time consuming and not concise or elegant enough. This one, a big shout out to the user on the Discuss board. I'm really inspired by him. If you like this video and you feel this video helps you understand this problem or the solution, please do me a favor and gently tap the like button. That's going to help a lot with the YouTube algorithm. And also, don't forget to subscribe to my channel. I would really appreciate it. I'll see you guys in the next video.